browser, my dude. To look at the chat and stuff.
Wait, what?
You need to see the chat, man.
I need to see the chat?
Yeah, we're live.
Oh, I see. You want me to go to Twitch?
Yes.
Okay. Let's just see some poor souls, some bots watching us. There's 0 people. Apparently nobody.
Okay. So let's just get that on going. So so just for the record, we have 2 things to do today. Maybe we're gonna skip one of them, which is to fix the REPL because it's now broken given the previous session, and
We always break it, man. Always.
not always. It was working fine for the previous sessions.
And then we change. We add some tiny thing and we break everything and then we
didn't
fix it
add
again.
a tiny thing.
Yeah, it was a tiny thing. Like we added a list. That was a tiny thing. We bugged everything. We had to fix it.
I actually don't even remember exactly what we added, but it was not a tiny thing. Oh, we added recursion. Yeah, that's definitely not a tiny thing.
That was not like ginormous.
No, but we changed the type of declarations. That's why everything broke after. Anyway, so we also want to start doing structural records. And what I mean with that is not doing the fancy modular system yet. We are gonna just do
What's that have to do with the
tuples with
modules?
steroids.
What does that have to do with the modules, by the way?
Well, as far as I can tell, records in OCaml, they are more powerful than just like Haskell records. So.
Oh, I think it's not the record, it's the module because the modules are a functor, so you can declare in the same way and construct a record from it.
Yeah. So we're not gonna do that at the moment. We're gonna do the structural one, which I believe is just tuples with steroids.
It's just it is literally just a tuple.
So
It's literally just a struct. Like that's the same idea of the struct.
yeah, but how are we gonna do? Is an n-ary tuple? So this is a list.
Well, yes. On the ST, I think it would be just a list of labels, of pairs of labels and a value. And a type. Actually a triplet then.
Okay, so we need a list of triplets.
Oh, dude, this declaration will be retardedly bad. But okay, let's see here
what do you
on the
mean
example
by
first.
retardedly bad?
Type annotating that thing. Like, because we will have to annotate, we don't have alias. So, like, when you say, okay, I want a record like this, you gotta specify on the function annotation the record.
I'm not getting what you're talking about.
I'll
Can
give
you
an
exemplify?
example.
Yeah.
Records. SW.
Yeah.
Wait, it's loading. Can you see where I am? See if you can follow. Okay, it's shoulder. So, like, think of this: a function ABC that receives an A that is a record of like a random thing. You will have to annotate it like this, like X nat. We don't have naturals like integer. I don't know what we're gonna do here. Could do like can do like V's or P's. I don't know, man. The syntax will just get worse.
Yeah, we're getting out of options. We're now using braces.
Yeah, so it is getting fairly. Yeah, okay. I have some options, but what I mean we have 3 options. So the first one. By the way, let's add comments as well. Like it's quite annoying not to be able to.
Yeah, but I will not vote to have the semicolons and stuff.
Why not?
It's so bad. I hate it.
Why?
I prefer the F sharp way.
What?
I prefer this.
Dude, you know the trouble that I have of typing this, right? It's not inclusive. The heck, man.
Okay, so the reason we're gonna make it uglier is because of Mageta's bad keyboard.
What do you mean uglier, man? This is cute. The heck? Like, and this is actually, like, for example, if it's 1, you comment already. And then people choose that you comment just a line. And then 2, you comment with some annotation or something important, like outside. 3, you put documentation. And then I don't remember if there's 4. But anyway. Or I don't know, man. This is easy to type, like, whatever, man. Just don't use this.
I can't believe
This bar. It's acceptable. Anyway,
We're gonna
or
make it.
this, or this. Like they'll come
No, I
or F
prefer
sharp.
the count of. I prefer the older bar. I prefer this. No, not
Oh
this.
man,
I prefer this in
dude,
comparison.
this even fits in the parentheses. Or about what about this then?
Yeah, you need to pay attention that parsing
This
that
could be
will
the
be very
block.
bad. So.
This voodoo could be the block. Anyway, let's go to the
Okay,
thing.
what about? Oh wait, but what about this? Single line in this blocks with this. Huh?
I don't like the blocks with that. That's really weird.
That's really weird, you say.
Why
Hmm.
not this, man?
Man, I don't want to use brackets because that's gonna make the parser worse.
What do you mean? Oh, I see. I see what you mean. Like because you're gonna mistake with the other
No, we
brackets,
can
right?
make that parser. It's not
I
hard.
mean,
It's just annoying.
well, we can just add this as a whole token, right? And then you try to parse it entirely.
Yeah, we can do that.
Yeah, but
That's.
anyway, like let's just continue. Decide later. Okay, so the first one of accessing the method, I think that's the declaring and accessing. So the first one is the common Lisp thing.
Okay, so this is the
I
common
don't
Lisp
remember
way.
if we used. So yeah, let me give a common Lisp example. So it should be something like def struct, if I remember correctly, and then a name like ABC, and then here you put all the things. So for example, a field X that starts as new and has a type, I don't know, or string list, just list, I guess. Or yeah, no, let's put list this. So this is this is that, and then we can have others here like this. And then I don't know, I'll start with 1, 2, 3, type a number, whatever, something like this. And then to access it, it makes some macros, but we cannot do that now, so we would have to hard code them, which is not bad, like it's fine. And then it would be something like commanders here. And then when you have an instance of this crap, like you just do, I don't know, ABC. That's bad. Some var. Okay, you got the idea. So this would be the value of x there. So it should be new. Something like this, you see?
Yeah, but that involves macros, I guess.
No, we can mimic this. That's what I'm saying. Or there is also the F sharp way and Okamo. F sharp. I have to switch my mode in my keyboard to
Oh
type
man,
this.
I
This is
want to
so
make this as the comment so bad now. You don't understand.
you want me to suffer, man. That's it. Okay, which is like you make a thing like ABC, right? You know this.
Yeah.
I'm just typing for more the audience, I guess. Oopsie, sorry, not this. This is the type annotation. So like a list of I don't know string. It's parametric, and then like y of I don't know int, whatever. So okay, and to access, how do you access? Well, you just do. Well, assuming you have a thing called var, no, variable, I guess. With that thing, you just do variable dot and then x, right? That's it. And the third thing, so okay, how do we adapt this to Lisp, right? That's the thing.
No, we also have the Haskell way.
How do we adapt this to Lisp? That is the question. Demus, we do this.
Here it comes. Oh my god.
That's valid, by the way. I don't know if Common Lisp does
In
that, but
closure.
Clojure, yeah, in Clojure you can do this, but on
But
records,
I don't understand why you don't want to do just X variable.
yeah, you had the dot. You mean?
Yeah, then it's gonna
Yeah,
be.
remove the
Then it's
dot.
literally gonna be the Haskell way, which is the
Yeah,
older type.
I think the dot is well to just basically say okay, this is because it's not for records that enclosure, right? That's for methods or attributes. So
Okay.
the usage is sort of different, right? It's just to say okay, this thing comes from that thing. It's not a function or something
Yeah, so
outside.
that's the thing. In Haskell, the fields actually become a function that pick the record
Yep.
and return the field itself.
So it's a
This is also
glorified
the way I
getter and a
chose
setter.
for my lib. I just generate the polymorphic functions that have the names of the slots.
And there's the other way, which is the closure records, just to, since Commander is here, let's that you do that.
He waited
and
just
then,
for you to join so you can cringe publicly.
Yes, exactly that. I do. Wait, just a second. Closure record. If I'm not going crazy. Def. Okay, it's def record, but there's a def as well to define anything.
Yeah, but
This.
I have a question. How exactly are you generating the functions commander in your lib?
Well, I mean, I do it with macros, but you
yeah, so that's kind of metaprogramming, right?
Well, yeah, but you have the interpreter. You have full control over your language. That's stronger than macros.
Yeah, but now I'm thinking, how the heck are we gonna make that mechanism of transforming a field into a function?
You just see the definition and generate all the necessary functions from it.
Yeah, that's the thing. So you said correctly, you generate stuff. So that's something that I never did in Haskell. How you do metaprogramming?
Oh, what do you mean generate? Okay, you're saying about interrupting, making a function that does that. I just make a higher function.
No, I mean, like, what do you mean how you generate stuff? You read the definition, you parse it, right?
Yeah.
Okay, now you have the parse like tree of the thing.
Yeah.
Now you say, okay, now let's define several functions. Can you do that?
Oh, we can.
That's it. You have their names, and you just define.
You just make one function, then you pass like multiple mini functions that extract position in the record.
Yeah.
I do think it's unnecessary though.
Well, we are evaluating the options, right? So we have
It's better to just
options.
have a symbol like this. I think this is the easiest.
Why do you want to have it look special? This is what I'm wondering. It's just a regular function, same as everything else.
Let me see.
So this would be...
On this case, it wouldn't, right? It would be, we would parse this as a symbol, and then the behavior would be trying to find this on the metadata of the ABC.
Yeah, but that's like, that would
It's
require
not a function,
total,
really.
it would require total symbol support, which we don't have at the moment.
Oh, we can add it. It's just I parse this and as a symbol.
Yeah, I want to look at the book, how the book is.
Then you can do these or the keys, whatever. The book is saying exactly the dot, man.
No, yeah, but what is happening behind the hoods? The dot is just syntax for our
Go
language.
up there. Go up there. Go up. There. That's it.
That is still not explaining what I want to know.
Ah, he doesn't implement. I think if he implements, he will be in another chapter, not there.
Oh, so
he's just saying like what to do. Yeah, he's just giving you the rules. Like you validate like this. Like implementation details, it's up to you, man.
You just one note. You definitely don't need to do the crap the command does in this case, because you can have proper dispatch mechanism in your language.
Yeah, I think that doing the common Lisp way and the closure way is going to be too much work for today. So I'm trying
what? The closure way would be too much work? What the heck you're talking about, man?
Yeah, of course it would. It's exactly what I said. We don't have proper symbol support.
It is the dumbest way. The closure way is the dumbest way.
Yeah, the closure way involves having symbols, which we don't have.
You add a node, the symbol.
Yeah, so...
No.
Or you don't even need... Okay, let's say, okay, you don't even... No, I'm giving you our implementation, right? I know closure doesn't do that. But let's say, okay, I don't want to make a symbol. Okay, this. Okay, what is this? You search. If you get this, and if this is not a function, and you parse this as a variable, you basically say, okay, is this in the metadata of this? Is it? It is. Okay, so get it for me. That's it.
Okay, that
what are you confused about, Lemus?
I'm not confused. I'm just thinking...
If you want to make it easier, we can even do this.
Here comes Magenta with the fancy symbols. What I'm not necessarily confused, Command. I'm just thinking how we're gonna implement this, because there are a lot of things to put into consideration. Whatever we do, we need to type check that thing, and we need to evaluate it. So in order to evaluate, we can do what Magenta said. That's fine.
You have all the type information from the parse tree already.
Yeah. This should be something like
Okay, that's true.
record. That should be like E record, I think.
Yeah.
Okay, maybe a literal, depends on what we're gonna do, but I'll do in F sharp because I.
Yeah, that's fine.
And what you have, it could be a list.
Of triplets, right?
A list of. Oopsie. Let me see. So we need the express. No, sorry. The expression.
We need the name.
The expression, the name. Yeah, but here's the thing. For now, we're not having a declaration of the record, right? We're just having like an anonymous record in F sharp, like this. And then when you annotate stuff, like for example, this is anonymous record. And when you annotate the type of this, is always this. So
Is always
like
what? Sorry.
like when you do the fun, like for example, the true ways, you do this, right? What is the type of this? The name.
Isn't that a ABC?
It is ABC. But if you make an anonymous record without this name, which is what we're going to do, which is easier, because we don't have the alias right now, like it should be the type is this whole thing here.
Wait, I am confused.
Like,
Because
okay, let me give you an example
can't we
here.
do like this?
Where?
Like
And
a record
okay.
being having a name, ABC, and also being a list of triplets?
Yeah, you can. Yeah.
It's gonna be like that.
Okay,
So
but
this
then
is the name of the field. This is the type
let
of
me
the
think.
field.
Let me think of the implications of this, because then you would have to find what is the body of this type in the environment, right? By the string.
Which one of them? You mean this one?
Like you would have to find this structure. Like, let me give you the example here. Like you by this symbol here, you would have to find this type here. You see? Because this is just an alias for this.
Oh. Oh, now I see what you meant with type alias.
Let me show an example
that makes
here.
sense.
Can I share? Oh man, why can I? Okay, I can. Can you see my alacrity? My terminal?
Oh, terminal. Okay, I got confused.
Yeah, so when you do this, I'll just do like two things. X, Y, string. Yeah, so what is the... If I declare something like X equals, I don't know, A, which is an ABC, I don't need to annotate. And then I say, okay, X equals 1 and Y equals ABC. That's fine. That is the value inside, and it annotated. It's an int. It's here.
No, not X. Sorry. No, wait. There's two X's. There's the X inside the field and the X outside in the let. What is the type of the outside X?
Here.
It is ABC or it is the brace stuff?
ABC.
Okay, so ABC is a proper type. It's not a type alias in this case.
Well, it is sort of acting like that because this is the reference for this type.
Oh.
So it's just another way. But I could do this. So.
Oh man, I hate these syntax.
Look at the type.
Oh, I see what you mean. So you can be a record with no name. You can be just a record.
Exactly. So if I do something like...
Do we want to mimic that though?
I don't know. That's in detail. So if I can even do this, like, okay, are they different? I can't even compare them because they are different types.
I don't know if I like this anonymous record stuff.
Oh, they're very useful.
Really?
Yes, dude. Without this, my life would be one 1,000 times harder.
So instead of having a proper name for a type, you guys are okay with having anonymously.
Yeah, what's the problem?
Yeah, it's bad because of course you prefer a proper name with semantics embedded, with meaning embedded.
Well, not really. Most of the time, anyone just buying some JSON bullshit. It's very handy.
That's exactly the application that I thought that this could be useful. That maybe you have a JSON that is just like nonsense, and then you can just like forget about it. Okay, let's try to see if we can do the one with anonymous then. So what would be the node? What the node would look like?
Okay, let's think. Okay, so let's ignore these for now and let's just think of anonymous. So a string, which is the name of the thing, right? The label. Let's annotate here. Label.
Yeah.
The second is, well, I don't think we need to do this, but let's just n. And the third is the value for it. And then from all of this, we can already infer the type, right?
Wait. This node, I think this is specifically targeted for anonymous records, so we should put that in the name.
Yeah, okay.
Because otherwise, if you when later when we add the type alias stuff, then we're gonna have to have a place for a name in here. Yeah, I think that makes sense. So this would be the name of the field, right? So this list would be this would be the name of the field, this would be the type of the field, and this would be the value of the field in the anonymous record.
We can make, I think, we can even make the type annotation a maybe.
But we don't have
Right?
inference. How that's gonna do?
No, wait. We do, because what we can have here, we know the type of this expression.
Oh, we can type check for the person.
Yes, exactly.
That's fine.
So we can infer this by this, because dude, it would be painful to have to write.
Oh yeah, it would be terrible.
So it's a suggestion. I don't know.
Yeah, that's not a bad suggestion. So let's copy that and go to the types here. So we just remove that. We put that as that. We need a label. We need a maybe type.
Can't you make like annotations by labels, like what I did with labels, like a name for this thing?
Yeah, you can.
You would need to make a record, I think, right?
You mean this?
No. I meant. Yeah, okay, you can do this, but that's an alias on the type, right? I meant a label on the thing itself.
That's an alias in the type. I mean the.
Yeah, like in F# you can do this, like I don't know, off and then like int, and then you say, okay, this is a label. So label this. In Nekoma, it's the this is also hard to type. This garbage
To
here.
do that, you would have to make a record in here.
Yeah.
Okay. Okay, so now that we have.
Wait. This is a list, right?
Oh, this is a list. Sorry for that. This is a list. Each one of those is a field.
Yeah.
So actually, kind of makes sense to pick this. And then you say type label equals text, and then you say that a type field equals this. And then you put there a list of fields. Just like that. Field. Okay. Okay, so okay, now the hard part. We have three things to do. We need to know how to evaluate this graph. We need to parse it, and we need to type check it.
Let's evaluate first. I think it's easier than parsing. I mean, parsing is not hard. It's just annoying, I think.
Yeah, this type of stuff I don't think is gonna be hard actually. What I think is gonna be hard is the other stuff that we were talking about before, the comment stuff. That would be annoying. But anyway.
Why? Oh man, I don't. It's so bad that I don't have completion or highlighting on here. I feel like in the 80s.
Anyway, eval expression. We don't have to touch declarations with this. So we have an environment, you have an expression, and we need to return a result for it. And and by the way, what is exactly it returns? What are anonymous record? What is the value of that? I'm
So
very
I was debating about that because that is already well, it is the same thing, right, as a list. Because a list can have multiple expressions, but the things evolved is the value of the list. You got the what I mean?
Can you repeat that?
Like, what is the kind of the list? Can we go there?
Yes.
Where is it?
Types.
Here, value. So a list is this, right? It's a list of values.
Yes.
So it follows the same thing because you can have expressions in here. Eh, Well, a list you can also have expressions, but when you make a value of a list, you evolve all the things inside of it, and then they turn into values. So it's the same idea, I think. It is the same node, but instead of being expressions, we make values.
Wait, I have a question. We have an anonymous record, right? Which is a list of triplets, right?
Yeah.
So I'm trying to understand. You said that the node in the data type value is the same as the list one, though.
Yeah, so let me get here. So it was like
So
this,
we
right?
would we would
What is a
evaluate
list?
each field.
Wait, and let's go by steps. So a new list is this, right?
Yeah.
And then we evolve it to what? To that, which is a value. We just evolve these things, which are the expressions.
Exactly. So we would do the same with the fields themselves of the record.
Yeah, so the records, a V record, I don't know, would be V's. I'll just copy the entire thing. But I think the rest can remain the same, and V's is values. Value, I guess.
So okay, that makes sense actually. That makes sense. You convinced me.
I'm persuasive these days. I convinced Victor to do illegal stuff these days.
Oh man, but now we're gonna
Yeah.
in the value data type we're gonna have types. Isn't that like that feels weird?
Yeah, that is weird.
I think we're gonna screw it. We're gonna just forget about it.
Yeah, but we can ignore it, yes, because we already have the value, right? It
Yeah,
doesn't
the
matter.
type the
Yeah.
the evaluator don't it doesn't care.
Yes,
So
that's true.
why should we care?
Yeah, that's absolutely true. Yeah.
Um,
Okay, so here, let's do it. So what is the first? Let me do the notation because I don't know how to live without it. So, uh, so let's iterate over the. So we just need to do what I just said, right? Which is iterating over the values. So values. Oopsie.
okay,
Can we
let's do no.
before? Can we dismember here?
Let's do the naive way. Let's do the naive way first. So names. There is a proper way, a probably better way of doing this. But okay. So it is expressions.
Oh, you're gonna make a function. Is that it? Or no?
No, these fields they are a list of triplets, right? We are not interested in
Yes.
this moment. We're only interested in
In
the
two of
third
them.
in two of them. You say.
Actually, yeah, the label as well, right? We need to mount again with the labels. Or unless we do in order, then it doesn't matter.
Okay, so let's put names. I don't know, names expressions. This will be equal to a map, which will pick a function with three things: the name, the type that we don't care, and the expression body. And then it will return this. It will return this, and then we map that to fields. Okay, so now we are basically filtering out. We are basically transforming the triplet to a simple
Yeah.
tuple with two things. And then the question becomes: what we want to separate those, right? We want to have the names
Yeah.
and the XPR separate, so we just unzip them.
Oh, that function was useful. I remember it.
And now we can do what you were talking about. So now we can do
Yeah. So
XPRs and then eval
XPR.
expression env.
Yeah, and these magic for short circuits for us, so we
Yes,
don't have
this
to
is already
worry.
doing all of that. And then
And do wait one thing. Do we? Oh man.
do we?
We cannot have recursive things, right? Recursive declarations.
Yeah, Yeah.
Okay, right now,
This is
if
not.
they are anonymous, we can't, I guess. Yeah, if they're anonymous, we can't.
Okay, that's great then. Okay, so now we pick all of these expressions, we
Just
transform them to values, and
mount
now we need to bind them together again, but then we just zip them together.
values. Wait. Does zip take a function? What does it do?
It picks two lists.
Oh, just this. Okay.
Yeah. No, these aren't exactly that. We need to do the peer that v record.
Are we even use? Oh yeah, we are using the do.
I think that should
Okay.
be enough. So now we have a v record. Yeah, that should be
We
it.
added there. That's it.
That should be it. Now type checking. Let's go the normal way. Let's keep
Typer.
parsing first. Parsing
So the
last, sorry.
type checking.
We're not gonna do type checking declarations. That's gonna be exactly the same. So type check expression again.
Look at this code, man.
Yeah, it's fine. We're gonna have the environment, and now we need to anonymous record, which is basically composed out of fields. And what should we do about it? I think we're gonna copy paste the same code.
Don't you need to do this below?
Where?
Below 53.
Oh, you do. You actually do. So let me pick that line. Put it here. And this needs indentation. Okay. So now the question is, so what should we do to type check this thing? That's
Okay,
a
so
great question.
Let's look at the book. It shows there.
Okay.
So the type of that is the same without the expression. So that's it.
Wait.
You just speak
so
the
an
expression.
anonymous record needs a specific node in the type.
Yeah. So
DST?
no. Yeah. So here's the thing. We don't. But if we just do if we have a declaration. But since we have the body, we type check the body, and that's the type of the label.
That makes sense. That makes a lot of sense. So we're gonna do the opposite of this thing, I guess. So we're gonna pick the fields. We're gonna forget about the name. We're gonna pick the type. We're gonna return that. These will be types. Yeah, I think we're gonna have to add a new node to the AST. That's okay. Then we pick the types. You type check them. I think it's gonna be here. Types. This guy will be an fmap reduce type. Type check expression. Passing the environment. That's okay. Ooh. Oh, okay, I lied. Okay, so this is wrong. So this should be this. Because we need both. We need actually the expression as well. So this will be this. Because we need to compare them one by one. So this will be a list of types and expressions. We pick the list of expressions. We type check all of them. Let's put expected types in here. These will be the types. And now we need to do a comparison. Am I going crazy? I think that, yeah, no, that must be it. That must be it. In the return of this, do we need the names though? Now I'm thinking. For type checking, does it matter? No, it doesn't. Yeah, it doesn't matter.
Wait, what are you type checking against? Are you type checking initial values to...
Yeah, so what we need to do, we have a record which is gonna be. I'm not saying this is the syntax. I'm just making it as I go. So imagine that this is the syntax of the anonymous record. So you have a x as the label, you have a type annotation as an integer, and you have a value as 1, right? What we need to do, we need to type check what is on the right part of the equal, because this can be whatever. This can be, I don't know, this.
Yeah. So
You need to
you type
compare
check in
this.
initial values to the proclaimed types, right?
Yeah,
Okay, got it.
we need to see if the type annotation that you gave is actually matching the
Okay.
type check expression of the body of the field, let's say.
Yeah,
Um,
that's okay.
so the question is, do we need the names though? Do we need to keep the names somehow? Do they
Yes.
matter?
Yes.
Well,
They
names
matter.
matter only for generating the accessor functions.
They actually matter there because you could. Well, they need to be associated with some. Well, in our case, if we handle the fields in order, we don't need the labels. Like if we have the guarantee, we're not gonna scramble them anywhere. But since it's anonymous, I don't think it matters.
Okay, so during type checking,
Only type checking.
we can ignore the names.
Yeah.
Okay, that's cool. Okay, now the question becomes: is we need to compare this list of expected types with the list of type checked types of the bodies of the expressions of the fields themselves. And then whatever we do, this will probably return this T record, and then a T record is basically a list of types, right, Mageta?
They're the same thing.
Expected types.
But again, that goes under the assumption that they are ordered, right? So the
That goes
first
in
type
the
represents
assumption.
that,
Yeah,
and so
there
on.
goes in the assumption. Um, I don't know if we should go with that though, because that seems so annoying when using.
I would add it anyway. I don't feel comfortable letting us do this.
Oh, okay, so it's a lack of confidence then. Okay.
Why
Well,
do
no,
you
no,
feel?
because in the future we will change this to, like, for example, recursive declarations. Think about this. Then how would you know which field is referencing which? Like, that's maybe you can find a way,
What do you mean by recursive field
like
declarations?
expression, and then you have a node inside the thing that it calls expression, for example. So it's defined in terms of itself.
Oh, I didn't think of that. Okay, so let me explain to you, Commander, what is he talking about. So right now, if we follow this way of doing it in the sense of,
No, I was having a question about why do you feel the need to first gather them in some sort of structure and then type check? Why can't you type check while mapping?
Why can't you type check while mapping?
Mapping.
What do you
oh,
mean
you mean
mapping?
apply type checking here?
Yeah.
We could. We would just have to use this other map. That's what we'll do later, but not now. We are doing the naive way first. Let's make it better after. Uh, okay, so but you understood what Mageta said, right? That the order will matter.
Well, yeah, but your problems with order are only arising from the fact that you're trying to first gather then type check. If you would just type check in this lambda, you
Yeah,
wouldn't have this problem.
I mean it's also good for display, but I guess there we don't need the labels, right? It's just like checking the types of the body. Sorry, the expression inside it.
Yeah, but now we need to check if the two lists are equal actually. So we need to do the following. I don't know. I never. I think we can just rely on the equality of lists in this case. We just see, are you equal to map reduce type, because we need to check if the type annotation is actually, like, we need to reduce the type annotation to see if they're actually equal, right? Um,
Yeah.
so map reduce the type, the expected types. But you are right, Commander. Just to be clear, we're doing it right now just because it's easier and just to see if it works. We want to do the least amount of effort to see if it works at all. And then later on we will make it better.
Okay, I just feel like, might end up doing more effort.
Oh no, it's gonna be easy. Don't worry about that.
At least that Haskell is good for. Like you just replace the functions in
Yes.
most of the
Yeah,
time.
it's gonna. I think it's gonna be even shorter than this. And this is gonna be like else. So this is gonna be 5 lines. Gonna be shorter than that after
So
I do
if
the.
they are equal, mapping the reduced types.
Then you were okay.
Hmm.
But if they are not, we should say where. But we are not gonna be doing that now because we want to make it just to see if it works. So we're gonna
There, the
say
labels would be useful.
exactly. So type error, we're gonna say mismatch the types between type annotation and types of I don't know, fields types in a record, in anonymous record actually. Anonymous. Okay, now we need to do the. Okay, so what reduce type does? Oh, okay, this is just actually insane to do this. We need to create this type though, T record.
You should say something like this. Our message should be error object reference not an attribute of a set or something like this. Or what was the error in .NET, man? .NET reference.
Where is the type? Okay, it is in here. So we're gonna have a T anonymous record. What exactly would this
Object
guy
reference
have?
not object reference not set to an instance of an object. Dude. This is so terrible, man. What the heck? This means nothing.
Okay, so now we add the node to the est here. It's just a list of types at the moment.
Yeah.
And I think that's it. So if we have a mismatch between the expected types and the types that we type checked, that would mean that we have a problem. Something is mismatching. If they are equal, these two lists are equal, we can just pick the expected types, wrap them with the new type that I just created, and then return it to the result.
Okay, so let's go for our beautiful def record. Or
the text on 65 is horrible, by the way. Even from my
65.
native speaker point of view.
Mismatch types between mismatch.
Mismatched.
Shouldn't it be type mismatch or something like this?
Also this, but then it will turn into type mismatch between type annotation.
Or just like mismatch between type annotation and fields type. That's weird, man.
No, fields types. There are two. There's this though. So this is this.
But a lot of
but
type in this
weird.
sentence.
Yeah, we are saying types twice.
Actually 3 times.
Actually 3 times you say. Oh, you mean this?
Type annotation.
Yeah.
No, but this is just for us to identify. See?
What about between the annotation and the field? And the field actual type.
And
the field actual type. And the actual type in the field, something like this.
And the actual type in the field, that's great.
Yeah, that sounds like type is in the field.
Oh. Type of the expression in the field.
Type of the expression.
Now expressions in the field.
Yeah. Oh, that was right. The expression is in the field.
Okay, so we are not. We're gonna go back to this later. That's fine. Okay, so now let's go to expressions because this guy is a new expression that you're gonna put in here. So let's think about it. So what is exactly? It is on record B. So parser tst expression. So what we need to do?
So
we need to decide the syntax, right? We need to decide the syntax of this mess.
So which one did we go for? I think to access, it makes a lot easier to do the curly braces. To access. Because we always know that this is the name of the field in this case. We don't conflict with other stuff.
What do you mean by access? Where are you, by the way?
Like doing, like, I don't know, ABC, click on my thing to follow. I am in the, yes. Here. So, like, doing this, I think it is easier doing this, like, oopsie.
No, but we don't have that, man.
What do you mean, man?
Yeah, we only have this. We are only able of evaluating and type checking if you have an anonymous one at the moment.
No, yes, but you need to access it. Like, how do you gonna pick the X inside of that? That's what I'm saying.
I think that's a separate conversation, but you're right. I was thinking on how to do this at the moment only.
Do you have curly braces even?
No, we don't have curly braces
So
at the
you're
No.
moment.
gonna add like the whole new layer of thing just to have this special syntax for fields?
What do you mean new layer?
Not layer, I guess, but like this whole new piece of syntax just to have this special thing for fields instead of just having the accessors as regular functions.
No, but it's up to us. If you want to add a new token,
Yeah,
that's easy.
I'm just asking.
Oh, I don't know. I like the idea of records being the only structure in the entire language that uses curly braces. Everything
That's
else
Why
the
do
uses
you like
something
this
standard.
idea?
different. Okay, can you
Oh, you
guys
said you
repeat?
don't like this idea. Did you say you like this idea or don't
No,
like
I
this
like
idea?
the idea of using
Why?
curly braces specifically for records.
Why?
Why? I don't know how to.
I like it because that's how everywhere does. Like in F sharp, Camel, Haskell, it's always like that. So at least that, even closure.
That doesn't make it good.
Yeah,
No,
that's not a good argument, but he
I
has
know
a
that's
point.
an unpopular argument, but
Why do you prefer the not having anything at all, Commander?
Well, I mean, it
I
just
think
makes
he
it more
prefers
uniform, I
this.
guess. What?
You prefer this, I guess.
Oh, this?
No.
Yeah,
As I said,
we don't have this though.
I prefer just X and then var.
Oh, so X acts as a function.
Oh no,
Yeah.
I'm saying this. Okay, but okay, we're discussing this now. I thought it was on this.
No, no, no.
I was saying this because it is easier to parse this
No,
way.
wait. You're right, Magetta. We are mixturing two different topics. So let's first discuss what would be the syntax for anonymous records, because this
Yeah,
involves
so you
having type
annotate.
alias.
So let's make an example here. I'll do it here because it's
I think we
polluted.
already have that in the grammar. Let me go there. Oh yeah, we
Do
already
we?
have that in the grammar. No, no,
No,
no.
no, no, no. We are not doing this, right? This
Yeah.
is declaring a record. We are making an anonymous.
Oh, okay. Sorry for that. So go, Magetta.
So X, and then we put the type, and then I don't know what would be the type. It should like I'll do in sort of like F sharp. It would be like this, right?
Yeah. Yeah,
Something like
exactly. It
this.
would be
How
like
do
that.
we replace this? I think this is pretty bad to see here. So
I would actually prefer to have not having the.
yeah, but we need a distinction between an anonymous and a non-anonymous. Well, unless you do the parsing and search, do a lookup, make a
Oh,
global
I think
state.
I know what you mean. We need a distinction between, because these can actually be
Yeah,
curly
this could
braces
be
for
a
a known record.
preconceived. Yes, exactly.
Oh, okay, that sucks.
If you do the def record thing, then it will be.
Hmm,
And not this, right? The value of it.
the
Then you're
value.
gonna have. Yeah, like, because this is just for a declaration, this syntax here. But anyway,
Yes.
we're not gonna use this. Like, and just. So what? Dun 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 dun. Let me invent a syntax here. No. Oh no, we're gonna use this for macros, right?
Yeah.
We're Mimi, man. I'm pretty sure.
I think that's even worse than the other crap. But okay.
Oh, this is beautiful. I like it. Don't you
Really?
like it, Commander? This looks gorgeous, man.
Gorgeous, you say. Gorgeous, you say. Huh.
And then to access the stuff, we can do the.
No, accessing is just a completely different discussion, because then I think I am with Commander in that case.
Oopsie. Let me maybe see. Think of this. Think of the possibilities, Lemos.
I
Or
am.
what about this?
It's even worse. You
This
have a
becoming
talent
worse.
of discovering worse syntax, Maggot.
This is. I could. Oh man, I could work on Rust design.
No, Rust is not as bad as we are doing.
Oh, the syntax is pretty horrible.
No, it's just verbose. I don't necessarily think
Horrible.
it is horrible. Well, but in the case of accessing I am with commander, X should be a function. X should
Dude, it
act
will
as
be
a
horrible
function.
to parse, man. It will be horrible to parse.
No, it will not, because this
Okay, explain to me how you parse this then.
is just a variable in the environment.
Yeah, okay, how do you add the variable in the environment?
No, you don't. You need to see if it is in the list of in the environment, and if it's not, you need to check if it is one of the accessors of one field of the records.
First, the accessors don't exist, so it is actually the labels. If there's any label with his name.
Yeah.
I understand what you mean.
Yeah.
But my way was just, okay, you make a special, I don't know, whatever here, and then you know that when you're parsing this thing with like these curly retarded braces here or whatever, like I don't know, this, whatever, some special thing. When you're parsing with this, you know that this is immediately an accessor. So you can already do that without extra effort. But anyway, that's a choice. It's up to you.
Well, we don't even have that working, right? Like if you have a special syntax for that, for instance.
Oh, by the way, let's add program as well.
Oh yeah, program is a very useful thing to have that we don't.
And I don't think our functions we can define multiple stuff, so we also need to add an implicit there.
No, no, but that's a fair question. Are we gonna have implicit program, or are we gonna force the user to use the program whatever?
I'm fine to force the person. Like,
I think it's fine.
it does work for us.
Two things. First of all, we don't have to call it program because this is, as Magetta would say, retarded name. You might want to call it begin.
It's not retarded, right? Because program, I understand it as an abbreviation for programs and programs.
Yeah,
so in Scheme it's begin.
In Scheme it's begin, but it's whatever. It's up to you. Also,
Enclosure
has prog1 and prog2.
That's bad. That's bad.
Enclosure.
Do is good. I like do, by the way.
Oh no, that's closure. Stop. I shouldn't have showed this. Let's still go with begin.
No, begin is bad because you expect an end, and
No. Begin. It says expressions, and we're doing it.
I hate it, but okay.
No, I don't care if you hate it. I'm not.
And just saying that if you don't want to have implicit programs, your functions will be full of programs.
Yeah.
That's why we are in the position to decide do we want it implicit or not.
Yeah, but I'm willing to delegate this burden to the programmer because there will be no programmers instead of just us suffering to add that.
That's a bad argument, though.
No, because dude, like I don't think it will be easy to do this because we now need to make the body as a list of expressions, right?
Yeah.
And then you just need to see if all the expressions in the middle they return unit.
Yes.
And then the last expression in this list returns like the thing which will be annotated to this body.
Yes.
So
why should the intermediate expressions return unit?
Well, they can return something, but they get ignored, right?
Yeah.
So it's like a loose type there.
So
it implicitly ignores them. So that's.
Yeah, that's exactly how we would implement that, Maggie. You would even know how to do
I describe. Yes, I do. That's why I don't want to do it because it's boring.
It is boring, you say. You're saying that is more worse than having to type begin all the time.
Yeah, if you will have you will have a let for
lexical
scope variables.
Just
you will have like begin.
Yes, I'm not gonna. But we're not gonna. Oh wait. Yes, we're gonna bootstrap this compiler, right? So
no, we will not bootstrap the compiler.
No, dude, I will. You know I will.
No,
That would be the ultimate
I don't know.
project.
I don't know which bet we're gonna make, but we're definitely gonna make a bet about it because I doubt it. I strongly doubt it that you're gonna bootstrap this thing.
Maybe not. Maybe Silverware with all the plus, we can do it.
Oh, but that's not as that's not unreasonable. But this is unreasonable. Watch Silverware Plus is totally unreasonable.
Oh, not really. You can do in assembly. People did this in assembly.
Yeah, that's why we never did it because we discovered it's bad. That's why we never did it again.
It's not because of that. It's because it was horrible and people improved.
Exactly. Why people improved? To not do it without having to do it again.
Yes, I know, but being horrible is not an argument. That's the point.
Yeah, that's okay. That's fair. Anyway,
Oh,
we are
by the way,
diverging here.
should another thing like we can embed the arrow, the threading macros as well to make alias stuff. That's also cool.
Okay,
Oh no,
okay.
this will conflict with the thing. We should do this then. Or this, I don't know. This.
Oh man. Anyway. So the
Anyway.
question now becomes, as far as I can tell, what we just did with the evaluator and the type checker is to be able to interpret and evaluate this, not this, not this. This will
Yes.
never work
Yeah.
at the moment. So we need to make a decision. I am in favor if the options are between this and this. I stick with this.
What do you mean? The exclamation mark is perfect.
Okay,
Oh, I'll
so
let Commander pick. I'll let Commander pick.
you
I
let
know
Wait,
he'll
wait.
pick
Can
this.
Commander
you
pick.
can you show the option again?
The other option is this.
Doesn't it raise attention? Like, look. Take a look here.
That's your
What the fuck
argument?
is this exclamation mark for?
Wait, sorry?
Oh,
What the
the
fuck is this
exclamation mark is
exclamation
to
mark
make
for?
it different than just this, because this we're gonna use when we have proper records with names and stuff.
Yeah, this is anonymous.
Yeah,
So,
this is anonymous without the type alias.
Man, this is like shit.
what do you mean, man? Syntax is perfect. Look at this.
Yeah, do something reasonable, please. Do like
I mean, to be fair, we can do just this now, Lemos. Let's do this.
And now that I'm thinking about it, because this is a list of couples, these guys require
We
parentheses.
don't need to add parentheses though.
I think we do.
No, not really.
no,
Oh,
you
dude,
don't.
what about this?
Oh my god.
Does that look better?
Somewhat.
I
Well,
think it
for
does.
me and my, tastes are very specific. I like the parentheses.
Because we are already using this for parametric stuff, like on a list.
Yeah, we are. We are using that for parametric stuff.
So it makes it more homogeneous, I guess, with what we have.
Okay,
Well, I
okay.
mean, is this what do they
Let me
call
just see
this?
one
Like
thing.
ticks,
Let me just
vertical,
see this.
vertical
it look-
lines. What that data structure do they represent?
Does it look better like this?
Wait,
Without the
wait, I want
think
to
of
address
without the
this
thing.
question. So you're asking what the vertical bar means.
No. So Magetta said this will make it more iconic or homogeneous.
Homogeneous, he said.
Yeah.
Okay, never mind then. My question is not.
Okay. So
Does that look better? Like ignore the fact there are no like parentheses. Yeah, the normal parentheses. Does this look better?
Yeah, I think it does.
I have to admit it looks better than the exclamation mark and curly braces.
Okay, so what about we try to reduce the amount of parentheses here, and when it's inside this thing, you know that you have always to parse two things at a time.
Yeah, that's okay. That's easy to do. It's not
Yeah,
bad.
so let's do it.
Okay, so let's do it then. So let's go to
Here.
expressions. So the first thing that we need to do, we need to parse. This is very similar to something like open delimiter.
My favorite function.
char, and then we open this, and then
Okay,
we
you're
say
gonna.
spaces. Afterwards, I make the applicative version with the between.
Does the open delimiter is with the? Wait, do we open a delimiter?
Oh, that's a good question. We don't need this.
I don't think. Yeah.
So you have a bar and then the spaces, and then we need to do couples. We already made couples so many times. So let me pick one of them. So what was the last one that we did couples? Declarations. Declarations, we made that. So this guy. Actually, we should make this a generic older parser to call as an auxiliary parser. But I'm gonna do that later. So annotation delimiter, yeah, and then you do that. So these are the couples. But these guys, they don't have the open parentheses. Ask
How are you
comment.
copy pasting so much code?
Man, how I copy pasted so much code? What do you mean?
Like it seems like you copy pasting a lot of stuff around.
No, I went to this
Oh,
file, I copy pasted here, I selected this, I copy pasted to this guy.
could it be that I'm typing as well?
Yeah, it could be the Magenta is typing, so you were confused. That's understandable.
Okay.
Okay, so that parses stuff given spaces, right?
Many.
Okay, so it gets. Okay, that thing is the value, the label, right, and the type.
Oh wait, this is not an expression, dude.
This is a type. Yeah.
This is a type. Yeah, so this is not in the right place. This is here. This is
yeah, let's just do it here and maybe move there.
Yeah, that's
so,
okay. So this is a T annotated anonymous record.
Two ends, right?
Two ends. You mean
On
here?
Yeah.
Are you sure?
I think so.
Okay, I'm not sure. So then I'm gonna fix the one that I did it here.
No, it doesn't have. So I'm wrong. I was typing unknown with double N.
So it's this. Okay, so this is the parser for it. So you have
for the types, right?
whatever name in the bunch of spaces in another type, and then you can do that many times, at least once.
Okay. So let's do it here.
I'm gonna remove it from here and put it in the correct place, which is in here. Type this. Yeah, I'm gonna put in this list here. Type anonym. Okay, so I parse it already. So what do we want to do now?
To declare it. So now it should be the same thing, I guess.
No, to declare it. What do you mean?
Unknown unknown dealing. Like to make a declaration.
Oh, okay, I'm dumb. It is because I thought, oh man, it is exactly the same. But instead of parsing types, we parse expressions.
Yes.
So I'm just gonna copy paste. Let's just copy paste.
Yeah, just copy. Just copy. Okay.
Okay, this. We actually don't need the do, by the way.
Yeah. Okay.
So instead of type P,
it's XP, expression P. Okay.
And that's pretty much it. We also need the do here. Yeah, we need an in here. Cool. And now we just add that this guy. We pick that, put in our list of types to parse, and that is it. What are the odds?
Now expression. Did you add the record?
Yeah, I already added in the list of possible expressions.
Okay. Oh, that's the one you add right now.
Oh
right?
wait. This is wrong.
Oh yes, it should be.
Oh, this is totally wrong, by the way, because this.
Oh, dude, yes, this we annotated with a maybe, right?
Yeah. So this is this. And we need to do something.
Oh, dude, let's remove the type from the thing. Like, really, it's useless. Like, we already have the type of the expression. Like, let's just infer it.
I don't know what you're talking about. I have no idea what you're talking about.
We don't need to parse a type in the thing because think about this. Like, what is our node? It is a list of triplets, right?
Yeah.
We don't need the type in the middle, the annotation.
Are you sure?
Yes. We get the type from the expression, right? We don't have inference right now, but we have a poor man's inference.
But that's the thing. When you do type checking and you did gave us type annotation, we need to check if type annotation matches the expression on the left, on the right.
But that would just make it uglier. Okay, I'm just trying to reduce our work, man, and you're trying to make us labor. What's our problem?
I just noticed that we have a maybe, so the typer will not type check because I forgot about that.
Do you have ambiguous types though?
Ambiguous types?
Ambiguous,
What do you mean by ambiguous types?
Types that might intersect by values.
No, like, because we don't have a dependent types.
Well, what I mean is like int 32 and int 64, right?
Yeah.
So if you have a value of 10, which of the two is it?
Wait, I am confused. Which line are you talking about?
No. He's saying like if in our language we have types that can intersect with each other. Like for example, yeah, for example, int 32 and int 16, they intersect, right?
Yeah. Okay.
I don't know how they work. I think it's with subtyping. I might be wrong, but
No, it's not. It's not the subtyping. It's just that basically the inference doesn't really work in that case. You have to default to one of the.
yeah,
Oh, that
if
makes
you have
sense.
to, yeah, I know that in F sharp, if you try to add an int 32 with an int 64, it fails. Like it doesn't know which one to pick.
It's.
Yeah.
I mean, the addition is one thing, but even like what I'm saying is the inference. If you don't want to declare types in your tuples, and you just want to infer it from the values all the time, you'd have to default to some like what you consider a sane default in the.
Yeah, I get it. Right now we just have like 3 types. This could be a problem later, but we don't have proper inference, right? This is not the inference we wanted because the
But
inference.
this is the whole purpose of the language is to make a language use type inference, right?
No. Here's the thing. Like what we're doing right now is like poor man's inference, right? It's not like
It's
making
not
a
actually
variable.
even. I wouldn't even call inference though. It's just
Yeah, it
like,
is
oh,
kind of that.
no, it
We're
is
getting from
not
the.
really, because you have a name and then you have a type that you're telling me this is the type of that, and then you have a body that is doing some crap. I don't know, like this,
Yeah.
and then I need to
Which
check
is an
if this is
integer, by the
actually
way.
this.
Yeah.
That's not inference because I'm not using it further. It's
Yeah,
just a
but
comparison.
but remove the integer.
Oh, if you do this, then it
Yeah.
is
So
inference.
yes, that's what we're talking about, and we are kind of doing it. But in that case, it's kind of dumb, right? Because well, why would you need to annotate? It's just bureaucracy. In that case,
Well, I don't know. I never
if you
used
don't have
anonymous records.
overlapping,
So
if you don't have overlapping stuff, yeah, I
wait,
don't think
so
it's a problem now.
wait, so when you do anonymous records, it's not useful to say, oh, this field's X, it needs to have the type whatever. You never do that?
When you are declaring right now with our types, no.
But you will in the future.
Maybe.
Maybe you say.
I don't know how we are gonna handle this, but maybe.
Are you sure? It sounds useful.
Did you get Commander's problem, by the way? That's a different thing.
Commander's problem is about what he said, intersection of like an int 32 with an int 16, I guess.
Yeah, so that thing would be okay. What is the thing on the record? But then in that case, in anonymous records, how do you do this? Like what do you infer to be the body type of that thing for the record? Does that make sense? Well, in the anonymous records, it always makes sense, right? Because you don't have any annotation. It will only conflict when you try to send the anonymous record to some random function or something else that makes, or like I don't know, gets the field and applies somewhere, and that will conflict. Like for example, think of the integer again.
No, but that's the
Like
thing. That's only a problem at the point that you can have ambiguous type inference. That's
yes,
not the
which we don't
case.
have. That's what I'm saying.
Exactly. Because we only have one side of integer. I think it's actually possible to. I'm not 100% sure. I may be saying BS right
No,
now.
yeah, but even if we had ambiguous on the records themselves, on the anonymous records themselves, this cannot happen.
This cannot happen.
Yeah. Because what is the type of the record? Well, you're defining it when you do stuff. Like, it's not previously defined, you know?
Yeah. I agree with that. But anyway, I think we are getting out of the way here. Commander's point is fair, but for the moment, because we don't have this level of granularity with our types,
We have Well, we have 3 types,
No, but I think that's what I want to say. I maybe say BS, but I think it's actually possible to inherit Haskell's type inference for this specific case of ambiguous inference. I need to check. I need to double check that later, but that's a different conversation. Um, for now,
For example, think of a record. We declare 2 records, and one record is some type that is, I don't know. Let's pick the integer again. So floats. So floats is not good. Okay, integers. So 32 and 16, right?
yeah,
So you have 2 records with the same name, the same fields, but only one field is of different type, which is 16, and the other is 32.
yeah,
Then okay, and then you just declare a thing somewhere, and then you should infer that this thing is from that type, right?
yes,
Right now we are obligated to annotate. We don't have inference that we cannot resolve.
that we cannot resolve. I agree.
So we don't have that problem on the records in specific, like of ambiguity.
Yeah,
But when we
ambiguity.
do inference, we will.
When we have inference, we will. And that's gonna be bad because we're gonna have to backtrack, I guess, because maybe some function call at the end of the inference will require something that will modify the first inference that we did, and then we have to backtrack that whole thing again. It's gonna be a mess, but okay.
Backtrack, you mean parser backtracking?
Yeah, because for instance, if you have, I don't know, let's suppose this expression we have here. So you can
Mm.
infer that this is an int, and then you can infer that this is an int, and that's fine. And then and you do like this, and then after a series of numbers, at the end we have a number that is not possible to represent using the integer that we were doing before.
Yeah, I see.
Then you're gonna have to, okay, can the other guys that I already did have this type that this guy is asking
Yeah,
for?
this I think we can leverage Haskell.
Yes, exactly. I think we can just say use Haskell's
By the way, I
system.
think we right now can define that, right? It's like a big integer.
No, we can't because I think Haskell's integers are 64-bit, but that's not like that's just an exemplification.
Yeah, I think
Uh,
floats would be better example. But anyway,
we don't
let's
have
just go.
floats, so we decided to have rationals instead of floats. Exactly, one of the reasons is because of that. Anyway, so we were discussing about having the type of notation in the fields of the record, right? And then you wanted to remove it, and then I'm asking why, if it's easy to parse anyway.
Well, it's just that it's horrible piece of syntax. That's all.
No, okay. So for now, I will make it to have it because I think it's useful.
Just keep in mind that
And
this
it's
was
useless.
said by a man who suggested those.
No. And it is useless. There's also that.
No, it's not useless because if you pass
It
to me
is.
a record that one of the fields has the same name, but it has a different type of notation, that is a completely different thing, right?
Well, but yes, you're dumb.
No, but that's what are you talking about? That's one of the purpose of having types is to say that people are dumb. What are you talking about?
Well, yeah, I guess.
Um, okay, so this is easy then because we just pick this. We said that this is actually a triplet, and then we put applicative, and then we just say we copy paste it from this guy because it's exactly the same as far as I remember. Option maybe, that's the one. And then we copy paste this guy, and then we put it here, right? We put it there. So yeah. So this is gonna be an option maybe of having spaces with a char, and then having the type, and then spaces. Yeah, it's done. Literally done. 5
Yeah, seems
seconds.
right to me.
But that's a problem though, because I just remember that the typer was not. I didn't do that considering that we have a maybe instead of a type itself. So I have to think about what we're gonna do about that. So da, 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 da. What if you don't annotate the type? Let's suppose that you don't annotate the type in any case.
On where? On
Type
the.
checking level.
If you don't annotate the type, well, you just get the type
Oh my god.
to the body. That's it.
No, wait, man. No, you don't get it. You didn't get it. Go to the type.
What? Oh, okay.
Oh my
Let me see.
god. Okay, maybe you're gonna have to remove it, but not because of what you said.
Wait. Let me see.
Ah.
What is the pain?
Okay, so are you here? Line 60 on the type?
Yes.
Yeah.
Yes, I'm
So the
here.
pain is that, let's suppose that you are a madman, and then you do, I don't know, X, and then you say that this is an integer, right? And then there's whatever going on, I don't know, whatever, literally whatever.
That is not a syntax anymore, by the way.
That's not a syntax, but just a simplification to you to understand.
Yeah.
And then this one you don't, right? Then we have a problem, because some of these guys will be types inside justs, and some other guys will be nothing, right? Then
Well,
how the heck are we
so
going to compare this?
yeah, you need to make a special function for that. Like the reps
Um,
that reduce type. So if there is something, then you do that. Otherwise, you don't, and then you just go accumulating.
so it would be a function that checks if the thing is a. Wait, can you repeat what you said, Magit?
Like you would need to do a function in that case that basically selects and say selects like the ones that have from the ones that don't have, and it behaves differently depending on those two. That's it, right?
And behaves differently depending on
Yeah, like
which.
because think about this. We want to what's the ultimate goal? Is to compare these reduced types to the type, right?
Yeah.
So we need to fail before, because think about this. What is the case for the
Yeah. So
annotator?
we're gonna have to
If
use
the
the
thing is
mapping.
different, then we just already fail, right?
Yeah.
If the thing is not different, then it doesn't matter. We just pick the annotated type. That's the same.
Yeah. Yeah. We're gonna have to use the mapping right now. If you want to keep the maybe, because another option is to just remove the type altogether, as
I
you
said
wanted
I
before.
said so.
well, because uh, we are doing Magetta style, let's do it then. Wait, so type checking anonymous records is just type checking the expressions?
Yes.
That's kind of meh, but okay.
Well,
that's that's. Oh my god, but okay, I guess. So this is just XPRs, and then we type check them, and then we don't need the if. You don't actually even need this, and then instead of this you put types, and then you remove the then. You remove this thing,
yeah.
and there are parentheses in the wrong place. Okay, so this is
We
just
need to
second.
add as well the kind checking. Let me add here.
We need to add kind checking. Oh, that's true.
Oh, dude, this will be kind of painful.
Why?
Let me see, because think about this. Like, depends, right? Because if they express like everything, all these normie types like unit, blah, 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 they are star. But a list, for example, and a thing, they are kind of parametric, right? So they receive other stuff. So what we need to do is basically check the internals of it and check the kind. If there's something inside that is other than a star, then that is wrong.
Oh, wait a sec. So,
Yeah, we're doing this with the list. I just saw here. So T record.
oh, we are doing that with the list. Okay.
Yeah.
I think we actually call it
So
anonymous.
okay, anonymous record. So what
Yeah,
is the
just copy paste the list then, and while you do that, I will fix the evaluator.
what were the parameters? Let me see.
So
Type.
this guy is also map second. How fun! It's just this, and then you zip them again, view record, and that's it. Um.
Um,
Oh, we need also to show. So when you have a v record with a bunch of well, when you have a record with an empty list, that would be just empty record. But when you have something with stuff in it, oh, I can't call this recursively because then it's gonna show empty record at the end. That sucks. Okay, so it's gonna be nothing, an empty string.
Okay, I'm not just adding parentheses everywhere, but I think just help me on this composition here.
That's fine. So when you want to show that, you're gonna have a label and a value. Then what? Then you're gonna print label, show label. So this is a text, so we may need to... How are you doing vclosure? Oh, we're not. Okay. So we're gonna do unpack the text to be back to a string. Like that. Then value. And you're gonna say show value. And then this. Then show.
I'm fluent in Haskell already.
Oh, really? Unexpected. Record access. Okay.
No, probably not.
Yeah, you're doing much better than in the beginning, so it's fine.
Star. Okay.
Okay, so this is.
Oh, we can just use an if.
This is a then, yes. Internal kinds or fields.
Okay, in this case we just peer star k. And else we throw an error. I think we can copy this.
Wow. Yeah, this seems to be correct. I'm impressed.
Okay. Did you check this? Does it make sense?
Yeah, it
like
makes a lot of sense. You pick the tuple, you pick the second, throw that to the kind checking, and the for will short circuit it for us.
Okay. So internal types of fields should have kind star and okay, this other is we will need to find to do a proper message, but I'm not with the will to do this now.
I also wouldn't. I would say Magetta would never do that. Who are you?
By the way, guys, how long are your sessions?
2 hours.
I think it's 2 hours usually. There was one that we did like 7.
Yeah, but that was not recorded.
Yes, we recorded 2 hours and stayed like 7 doing it.
Actually, you stayed 7 because I stayed with Nathan and we completed 10.
Oh man.
Yeah, programming. Okay, so let's see what stack tells us. Something needs to be wrong. I can't believe
Dude,
we did that.
If it just compiles, man, I'm gonna.
No.
What the heck?
No.
Yeah.
No.
Wait.
Okay, not in scope label. That makes
Dude,
sense.
I had one professor at uni that he typed in the terminal like all the class in nano because he didn't like Vim.
No.
So on the labs, like he would basically like close all the windows and just like keep typing on nano, programming C, doing like threads and all this bullshit in C.
Man.
Yes, nano.
Why?
And then he would like compile with wall like a bunch of flags, and then no errors. Like I was really astonished, man. Like that was like years of training.
Yeah, that's a lot of effort.
Yeah, he was from networks, so that's kind of impressive actually. Like to do like threads and sockets.
Oh, this is wrong. Okay, let's fix the parsing problems. There are some people that they are complaining. So variable not in scope, variable generic. I think it's because types never asked for weird names, I guess.
I think I posted something cool with a nano in the chat.
Let me see.
Let me just take a look on the time.
You
Okay, so
sent a common Lisp function called ed implementation dependent. Provides a his resident editor. If X is new, the editor is entered. If the editor had been previously entered, its previous state is resumed if possible. Why? What?
Yeah, so it doesn't work. Just for the record, it doesn't do anything on most of
your
the
microphone got
implementation.
fixed? Weird.
Yeah, it's sometimes it does the and then it goes like
Weird. Okay,
no, it's
I
fine.
figured out the problem. So when we are doing stuff, because we are ignoring the names, we actually need to parse it, but we ignore them. That's
We need
kind
to
of interesting.
parse, but then we ignore them.
Yeah, so this is actually types.
Oh, I
And then
see.
this function is pick the name, pick the name, pick the
Let me
type,
see
ignore the
if
type.
there's anybody on Twitch. No, there's anybody. There's nobody.
Yeah, I figured.
Actually, there are two. I think one of is me, but
Okay, so what is a better way of doing that? ID. Makes sense. No, it's not ID. It can't be ID. That doesn't make sense.
why would you fmap with
Yeah,
ID?
okay.
Salude.
Types.
Bendiciones.
Next. It is. Oh, the expression one is wrong. I was fixing the. Wait.
The type.
Yeah. No, but this was wrong also.
Hmm.
So it is complaining that it
Yeah,
doesn't
both are
have.
the same.
Both are the same.
Yeah, there's no
No, we
distinction. Like
removed,
the
dude. We removed the
oh, the
maybe.
type. Yes.
Yeah.
Okay. Just
So
one.
this is done.
Oh, so much better.
Uh, so E anonymous record. Let me just double check if we are doing it correctly.
I think we did remove. Mm.
Okay, so it is a
Yes.
list of fields.
Of
So it needs to be
labels.
a label and an expression. So it needs to be a list of tuples.
Are we doing a list though? Are we constructing a list?
No, but
Oh,
we're
the
using the
many.
many. We're using the many.
Yeah.
So
Mm-hmm.
this needs to be a label and this needs to be an expression. And those are, in fact, correct. So what are you complaining about? It is saying that it's expecting a list of fields and instead got a list of tuples. Yeah, but a field is a tuple. What are you talking
Wait,
about?
the maybe type is there.
The maybe you say.
Yeah.
Didn't I save stuff? Am I not
Oh, you
saving?
didn't save that file, the expressions.
Oh, maybe that was it. I doubt it though. Strongly doubt it. Okay, it was.
Okay.
Wow. Okay, so
So
evaluate to
evaluate
75. 75, 75. This guy. So
names. It's complaining. Names.
names.
What is names?
Oh, we don't have names
Yes.
because we're just
The
picking the
labels, right? That should be
things, the
the labels
labels.
portion.
Yeah.
Yeah, but okay, the zip should take the labels and the expressions. Which is which?
Yeah. So we're actually gonna do unzip
Oh, map
fields.
first. Wait, not really, right? We need to.
Not really, you say.
Yeah, like we're getting you're deconstructing a tuple there. Don't we
Oh,
need to
oh no,
map?
yeah, no, you're correct. I forgot.
Yeah,
This.
why don't you just do the first and map the? Okay, that's the same thing.
No, why why don't do this?
Yes, that's what I'm thinking. Because yeah.
Zip names XPR. So it is expecting a list of that, and I am doing something different.
Oh yes,
of
you need to evolve the yes. Yeah.
And almost there.
Okay, it's
So
on
I
the
think
typer 204.
204 on the type.
Oh, import list probably, or mistype.
I
Anonymous
T
record.
anonymous. Is this written correctly? T anonymous record. And the type that we have is the name T anonymous record as well. So let's just pick this.
Did you add to the export list?
I think I did because it's
What
already
about import?
it is already here.
What about import?
What about import? You say it is.
Aha, there.
Oh yeah,
Line 6.
it is in here. So T anonymous record. Okay, now it is the function that you did.
Oh, what a pity.
Ooh, that's a hard one. It's talking about A0 already. Okay, let me think.
Isn't that just inference?
Oh, no. I think
Oh,
I know
that thing is
I know exactly what is the problem. It is
yeah,
exactly
the
what
kind
you.
check. Yeah.
It is exactly what you and Nathan correct me a few sessions ago. So if you want to do composition, like you have some options,
That's
right?
a monad, right? That's a result thing.
No. You need to use the fish. You need to use. I think it's
Yeah,
this.
yeah.
No, but well, we can.
Yeah, it makes sense because that was a monad. I forgot about that.
No, but let's just see if the naive way works, and then later we make it better.
Oh, why don't you try already? Just both.
Why you said? Why don't you try already?
Yeah, just you had it previously typed to the. Anyway, just compile this. We'll go.
No. But HLint is saying that this is equal to what we're doing, so this is wrong.
Yes, this is wrong.
So what is the
Oh
type?
no, dude, wait. This is not solving the issue, right? We are not f mapping the thing.
We are not f mapping, you say.
Yeah, it should be f mapped, right? Like because here's the thing: we are doing second on a result type, like either.
Oh. You are f mapping. Wait, let's double check the type signature 4 because I already forgot.
Yeah, I think the problem is not even the 4. It is just that we are applying second to a type that is packed on something else.
No. But the function at the 4, the second parameter of the 4, the first one is correct. Is a list of fields. Each field is a tuple. That's okay. But each function, which is the kind check, this can return something else, which is an either in our case.
That's not a problem. The problem is the second, man. We're trying to apply second on the either. It doesn't make sense.
No, but this X is not an either, man.
No, dude, it's not. I'm not talking about the X. Go back there.
Where?
What is the result of kind check with environment? Inv.
This is an either.
What are we doing there?
We are
It's not
grabbing
this.
the X, we're grabbing the second member of this tuple and applying that to kind check with environment. That's it.
Okay, so it's reversed. I thought it was the opposite.
Oh,
Oh, I forgot that it's right to left. Oh, it's
no,
like
well,
manga.
you want to, if you want to do like
Yeah,
that,
no,
you can, but well.
Wait, it works.
No, but that's just HLint. No, it is just HLint saying that it doesn't have a hint
Oh,
for
I
you.
see. Yeah.
And this. Oh, and by the way, this is the way that you reverse instead of starting from the
Okay.
from the right. Good. You start reading from the left.
Put the fish man back. Let me see one thing.
I think you're talking about doing like that.
Yeah, let's see. Let's see if it compiles. I'm interested. And check the annotation later.
I have very not hope. Okay, so this is not in scope, so I think we removed it at some point.
A control monad.
Control monad, yes. So just import control monad. No, I can just do like that. Okay. Yeah, it's bad.
Wait, text style kind. I can't even read this, man.
It is because it is bad to read because of the type stuff.
Yeah, it started to put
Oh, I
generics
think
there.
I think I know how to fix it. I think
That
it
looks
is
like the
reversed.
transformer.
No, it is a transformer. This
Mm.
we're not returning an either. You need to remember that. We are returning a transformer of the either. But I think the error is just reversing this guy. Like this.
Oh man.
No, it's not. Let me think a little bit. So let's just read the type notation. Read the type notation of the 4. Um, so you have a traversable of a's. In our case, it's a list of
And then you
tuples.
apply.
And then you're going to apply a function that picks a tuple and returns whatever is applicative. So what we want to do, actually, is to do what I said. So you pick a tuple. X is a tuple. You can actually pattern match it in here. So pick X.
Yeah, we don't need the second here.
And then you just put X in here. And then I forgot a comma. That's it.
Yeah, this one.
It should work just fine. Okay. Quantum match expected to... Oh, okay. Oh, wait. This is not... this is not a tuple, man. This is the type for anonymous record. So this is just a list of.
Oh yes, so it's a list of the types only, right? You
Yeah, so
don't
this
have
is
the
this.
labels. Yeah. Okay.
We don't have the labels only in the
Yeah, I
evaluator
thought it
level.
was the fields. I thought it was the same. I said that would cause trouble removing it. Okay, dude.
Okay, it compiles. That doesn't mean a lot, but it compiles.
Yes, try it. Yeah, let's try an example.
Let's make an example now. So go to the record.sw that you made. Okay, so now you need to make a function. That's fun, yes. I'm so glad we have this. It's already powerful enough to test it.
How are we parsing these couples with a parenthesis?
No, we only
without?
spaces. Only spaces.
So okay, this should work. I think.
Yes, this should work.
Okay, this and then just we don't have a print for that thing for now, right?
Yeah, no. For now, we're just testing if
Let's
we
just
can print something to see if
parse.
parsed.
ABC.
Yes.
Okay, and then we're gonna call it
exactly because this is just returning
unit.
unit.
ABC, and then constructing a thing that is exactly the same. So how we're doing with equals?
I think it's with equals. Let me double check that.
Just check there.
Oh no, we're not doing that, but I will make it to do that. So it's a variable generic, and then it's going to be this char, actually string, space, this space. Okay, it should be it. And
is it that?
Wait. Yes, I think it is that, actually, because it's a function that receives a anonymous record, and then this is so weird, not having anything to separate the. This is weird AF though.
Yeah, Clojure does that, by the way. Well, Lisp as well, right? It's like in a list. You know what I mean, it's always spaces, but well, it's not three things, right? It's different. It's always one.
Okay, so let's see how that works. I first need to rebuild it because I changed the parser to have the equal now, but that should work flawlessly. Okay, and then let's go.
This should work flawlessly. And
No. This should compile flawlessly. Work? I have no idea. Unexpected parentheses at line 3. So line 3, which for some reason we had a lot there lining around.
Parentheses, so the closing or the opening?
I think it's the closing. Yeah, it is the closing. Column 38. So it's this. So it's not expecting that one to happen.
Yeah.
Which is weird. Because
Probably
that would mean that we don't have the parsers aren't working correctly. So there's a way to fix that.
I'll go have dinner. I'll be back in a bit.
Yeah, that's okay. So let's test the parser.
Just a second.
So we're having problems with this guy actually. So type in record. Do we have that? Type in. We don't have that. Okay, so I'm gonna just that. Um, and I think in the parser, we're also going to have to export the parser types in order to that to happen. Cool. Awesome. It worked. Let's see if we have that. We do have that. Awesome. So now we're going to import our text parsec, and then we're going to do type record. We're going to not use a file, we're going to use this. Let's go to our example, which is it this? I guess. Let me double check. It is a type P. Okay, so yeah, so it is just that. So it is just this. Let's copy that. Let's paste it. Let's parse it. Variable not in scope. Oh, I don't know how to type. Okay, that makes sense. Unexpected end of input. That's very weird. What are we doing here, bud? We have this in spaces. Then, oh, okay, so we actually need to have open and closing because the spaces are reversed. Actually, we can also try to just YOLO it and put spaces in the beginning as well. Yeah, there's gonna be that. Why not? Unexpected end of input. We are doing something fundamentally wrong here. We parse this, and then it's a between this thing. So you actually take care of that. And then you say, oh, I have that. Let me take a look at the variable generic to see if it is the one that is correct. It is. It's already 143. You put type P in here. Oh, generic there. And then you map that, removing the name. Removing the name to just have the type, and then you do many of those. I am confused. Unexpected end of input. What if I do this? The same. Expecting white space, integer boolean. What if I give you a white space? Expecting white space. Unit integer. So let's for now copy this guy. See if we want something like that. Remove this, do that. Oh, I didn't see this error, so could not load module parser. Oh, ambiguous type variables. Okay, so we never actually made it work. That's why I was so confused. Okay, now it is working. So that. Still unexpected end of input. That's curious. So let's delete all of that. Let's put this parser in here. Let's call it a test. You are a parser, right? You are a parser. That's cool. Then we're gonna go to here. I'm gonna swap this for test, and we just wanna focus on having these two. This works. So the problem is the between. Weird. Very weird. So let me take a look on how we were doing betweens before, because I'm already forgetting about it. Open the limiter and close the limiter. Open the limiter. You always focus on the char itself, apparently. So this is wrong. Because it is... How is it open the limiter? This. So that. Then spaces and there. There it is. Okay. Why? That doesn't make sense. That doesn't make any sense. Are we dumb? Let me do it the naivest possible way. Spaces. So you're gonna parse that. Then you're gonna parse this.
Okay, how's it going?
Yeah, so the parser is not working for a reason that I still don't understand. So what I'm doing, I'm just making it even dumber.
So let me see. Oh, do notation, I like it. So that char, okay.
Spaces.
Then you do types.
And then you're just gonna do...
Why? Okay, because you need to pay. Okay, you need to get two things, right? The labels, which you don't care, and the type.
Yeah. So I'm not understanding why. The problem is with those vertical brackets. I am 100% sure of that. Actually, the menu one needs to be here.
Mm-hmm.
And you just put types here, I guess. Let's see if this works. It doesn't. Interesting. So in the statement for do block, in the expression there,
Couldn't match.
pretty much expect the type with actual type, it says.
Can you open on the REPL, like on the stack REPL, and execute this?
Yeah, I did already. But
Okay.
it was not working. It was
Because that's a type
unexpected end
mismatch.
of
Let's
input.
see the structure it's doing.
So
Oh
this
man,
is,
it's
it was like this. It was like this before. Yeah, like that. So we started to do. Um, and this is not working. But I already tested this part. This part is working as intended. It's exactly what we want. But when I call, instead of this entire line, I call this, and I put the, the vertical bars, it is not working. So that's what I don't understand. We must be doing something really wrong.
Yeah,
Really,
that's
really
strange.
wrong. That's very strange, I agree. Very, very strange. Because look, I'm gonna even do it from scratch just to simplificate. Okay, so then we import test parsec to have the function. Okay, so look at this, right? So we are
Yeah.
calling the type in record parser that we're just looking at, and then we have the vertical bars. That is saying unexpected end of input. That doesn't make sense, especially because if you pick the line, so look at this line is the line that we have there. So then if I swap this with this and remove the bars, it works.
Yeah.
So there is something really dumb going on.
Okay, and we are using between, right?
We are using it between, yes.
Can I see it again?
Yes.
Between char spaces. Oh, wait. No, no, no. I don't think it is that. Did you try? Okay, you tried. Can you try just a between, like a sample? Like, don't with the same. Go back there.
Like where? Here?
Yeah, put the same, the test between, like make a between.
Oh, between.
Yeah, put parentheses. And do like, I don't know, comma, whatever, some random thing.
And you put sha, comma, sha, comma.
Yeah.
And that, and that. It works!
What the heck? Add only the bars. Only the bars.
Add the bars, you say. This.
Yeah, because we have spaces as
We
well,
have
right? So
spaces,
just add
that's
that.
fair. Still works?
So if as long as okay, try adding the spaces and check. That's strange.
Works still, and
Yeah, the
it
problem's
still
on the
works.
right.
And then this should be spaces
Oh,
here. Right?
yes. Are we doing on the right place though?
What the hell? Now it's working! This is exactly what is written there.
Copy
What
and
the
paste, man.
heck?
No, man.
That
Copy
doesn't make
that line.
sense.
Copy the line and paste it
That
there, and
doesn't
just
make any
change to
sense.
test. Can you map? Oh, yeah. I don't think it is that. Many types. Yes, dude. It is the same thing. What the heck?
Okay, maybe the many is wrong then.
Yeah, it could be. The many returns a list, right? No, it returns a list wrapped in a parser, right?
Yeah, it returns a list in a parser, but the many one is the one that requires at least one. I don't remember.
Mm-hmm. Well, yes.
Wait. Okay, no, but then we can still test it here. We can just add many.
Oh, spaces, right? Oh, dude. Spaces on the... Yeah, add spaces on the
Oh,
test.
that is it. That is it. Just one moment. Okay, so it is
I don't
just a
think we
matter of
need to add
adding
parentheses.
spaces there.
Yeah, like, oopsie, the opposite, right? This.
The opposite is. Okay, so that import test parsec here, and at some point here. Unexpected end of input. Did I save? Yes, I saved. That doesn't make sense. Okay. So
Add on the wait, let's swap the spaces and add on the beginning. I think it could be that after the bar, it doesn't know where to find the spaces.
after
So
the
what
bar,
about this?
doesn't know where to find the spaces.
What about this? Oh,
After
let me
the
see.
bar, it doesn't know where to find the
Yeah, the
space.
initial bar. Actually, not the bar, right? The after the first couple, it doesn't know where to find them. The like with the space in the middle. We're adding on the end, so
No, still
yeah,
wrong.
no.
No, but
Dude,
there
what the
is
heck?
another test that we can do. There is another test that we can do in the REPL. Let's use and abuse the REPL. That's the secret. Okay, so this is throwing us the error. So then I have a question. what it happens, so it is in the many. The many tests something is wrong. So then let's attempt to put
spaces on both sides. It's the
no.
opposite, right? No, it's the opposite. It's like pointing to the left, right?
Oh yeah, sorry, pointing to the left. Yeah, that didn't change anything.
Put spaces on the other side as well.
Put spaces in the other side as well. Oh, you mean before the test?
Yes, because on that case it's before, right? So let's see.
No.
It doesn't, dude. What the heck, man? What
This
the
is
heck?
weird.
Many one spaces test.
It is something related to having a bunch of spaces. That's for sure.
Yeah.
Because you need to pay attention that test also has a bunch of spaces. Look, the variable generic is just surrounded by spaces.
Yes.
Okay, let's try to remove some of the spaces because maybe we're being not realistic. So let's do like that.
Yeah, but the spaces are optional, so it's like some ambiguity that is.
And then let's do like that. Yeah, like this. Yeah, it is shadowing, I know. Then, in the test itself, we put it surrounding. Okay, no, never mind.
These
Weird.
messages suck for the user.
Oh, it is saying the coordinates. It's line 1, column
No,
13.
yeah, but for the user, like, he doesn't want to see the expecting white space, blah blah, like that kind of stuff.
Yeah. So we are already counting for these amount of spaces there. Then we have the many. I wonder if what happens if I remove the many. Ah.
So the
Okay.
problem is the many.
So the problem is the many. How does that make any sense?
Try just the many instead of many one.
But then we're gonna have a problem.
Yeah, I know. I know how to fix it though.
Expect.
Yeah.
Yeah, that's bad. I know what you're gonna say.
Optional, right? I mean, you can smell my bullshit already.
100%. 100%. 100%. So how we are doing this when you have, for instance, multiple declarations? We are
Yes,
using many
good
there.
point. Yes,
So
but we have on the couples we have a delimiter for them, right?
you think that's it?
Try adding delimiters. It will be ugly, but just see if it works with that. Because I think it is not understanding the difference between the spaces outside and the spaces between the x and the thing, the integer.
That's weird. Wait, so your idea is what is the problem again?
So my idea is changing this test to be parse the tuple with parentheses around it.
Oh, we are missing something related to spaces because the menu is getting crazy. It is expecting to have more stuff. It's expecting to have more stuff, more stuff. That doesn't make any sense to me, man. I'm
That
sorry.
doesn't. Why don't we try to rewrite this scratch? Like ignoring the that we already did the couple.
Well, we can. I don't think it's gonna make much of a difference.
Well, let's try, man. It's better than like blindly testing. Or write on the REPL. It's easier to test.
Okay, so well, the test parser I think is the same. This. So it is
So
a
let's see.
parser that picks a variable generic, which can be names for variables, like whatever variables, not necessarily type variables. Then you have spaces.
Wait. Not only that, right? We pick. Oh no, dude. I think and a type, right? So it's a tuple.
Yeah, and the type. And the type. That's important.
And we need spaces, but we pick on the thing on the left, which is the variable.
Yeah, we're gonna
And
ignore
they
the name,
type.
and the function that we have mapping later is something that picks the two things, ignore the first, and returns the other thing.
This is perfect. Dude, what the heck?
Yeah, that's what I'm saying. I don't. Oh, and by the way, we can do it again. We can do like parse test, and then we can put this requires this, and then we can put x integer. Right?
Mm-hmm. Yeah.
actually we don't need to do the other stuff. So let's do the many one. So then let's separate this using spaces.
What?
Okay, this time it worked. Then we're gonna do this. Ah. Okay. So we need another type. This. Okay, so this works somehow.
What the? What? We did nothing of
This
different.
seems like a bug though. This is sounding like a bug to me.
Can you add a space on the end, like after the string? Before? Okay, we don't have one in the beginning. That makes sense.
Yeah, but that is what the between was doing. Look.
Yeah.
So this seems like a bug.
Let's see on the between.
Parser.
Wait a second. Can we delegate the between garbage to inside the menu? Because the spaces are optional, right? It's an optional parser. If you don't have it, it does nothing.
The spaces are optional. What do you mean?
No. The parser spaces. If it doesn't see a space, it doesn't do anything. It doesn't break. So do the following: up twice. Put spaces pointing from the left to the right as well. Don't remove the other. Just put spaces there as well. It works. So try adding a space on before the X. Okay, between X and integer. Okay, so it seems since it's working, now try adding this with the between. But with the between without the spaces in it. Just the character.
Okay, let's call this test2. And then we're gonna do the between stuff, which is this. So instead of that, we're gonna do test2.
Yeah, and remove the spaces.
Remove the spaces.
Yes. These and the other as well.
I think we're gonna have to have parentheses regardless.
Yeah.
No! Still wrong!
What the heck?
This seems like a bug in the library though.
Dude, what the heck? No, dude, we're doing something wrong. Like, there's no way. Line 14.
No, there is
No,
a way.
column
We open an
14.
issue on GitHub.
What is column 14?
Column 14.
0, 1, 2,
You're gonna count that?
3, 4, 5, 6,
4,
7,
5,
8,
6, 7,
9,
8,
10, 11, 12. There's 12.
12.
Or did I miscount it?
Oh, at the end of the line?
Yeah, probably counts, but... What?
Yeah, it is changing accordingly to... Let's make it the smallest as possible. So this is the smallest. I think 12 must be here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
11, so probably end of line. Oh, add a space on the end, after between. Spaces. Yeah, after the between, add the spaces as well. Could it be that? No, it does. It is not.
This seems like a bug though.
Dude.
This is too simple to not work.
Yes, this is stupid.
So it is an interaction between having a between and a many. Did we ever do that before? Because no, we do. In the expression application, we actually do use a between in combination with a many, and it just works.
Remind me what is the open delimiter again? I think it has spaces inside, right?
It has spaces inside.
Oh, but notice we're adding the spaces on the both ends, you see?
We are adding spaces to both ends.
Inside the many.
Yeah, I see that. Didn't we already... This is, I think it's
exactly we already added on test 2. Yeah, on test 2.
Where is test 2? Because
there.
It's already lost in the middle of stuff.
I saw it
here.
somewhere.
Yeah, we already have spaces in both sides. We don't have extra spaces on test anymore, so I think we don't have it. It's just this. So a between. that is using a mini one inside. It is exactly what the application is doing. It is exactly this.
Yeah.
So something is very broken. And we are too dumb to undercover it, I guess. That's fine. That's part of the job. No, it's not every day
Thank you.
that we are a genius, man. It's fine.
Thank you for smashing my self-esteem.
Okay, so I'm gonna finish the stream.